This multiplication problem has some missing digits. The multiplication uses all digits from 1 to 9 exactly once. Maybe take some time to think about how you would solve it. The approach we are going to take is a series of estimations. So this is a great problem to learn how to do rough estimations and how they can be helpful in maths. Let's start by assigning some names to the missing digits. I've assigned A, B, C, D, and E to the missing digits shown here. So 8 multiplied by C results in a last digit of 6 with some possible carry. The possibilities for C are 2, 8 times 2 is 16, or 7, 8 times 7 is 56. However, we can see that 2 is already been used. It's one of the given digits. So which means C cannot be a 2 because each digit from 1 to 9 is used exactly once. So that means that C must be a 7. I have added on the left here a legend to track which digits have been found and filled in and which digits are currently missing. For example, at the beginning of the first step, the missing digits were 1, 3, 4, 7, and 9. Then we found that C was a 7 and we filled that in. In this step, we are going to focus on this missing digit A here. The possible values for A are the remaining digits 1, 3, 4, and 9. But if we look at this number, A be 8, can A be a 3? Let's try 3 something something multiplied by 27. This number will always be greater than 300 times 20 because 300 is less than or equal to the first operand and 20 is less than 27. So we can clearly see this number is 6000. What that tells us is that A cannot be a 3 or anything larger than 3 because if A is a 3, the result is at least 6000, which exceeds 5DE6. This means we can eliminate all digits greater than or equal to 3, and A cannot be a 3, a 4, or 9. That leaves the only possibility for A to be a 1. The next digit that we are going to focus on is this one here, which we call D. Let's see which values of D make sense, similar to what we did in the last step. Let's see if D can be 4 or 9. What we notice here is that the first operand is of the form 1 something 8, which means it's less than 200. Our result has to be less than 200 times 27. Times 27 is also easy to calculate because we know 27 times 2 is 54. So 200 times 27 is 5400. So we know that 5DE6 has to be less than 5400. So that already eliminates both 4 and 9 because if D is 4 or 9, we will get a result larger than 5400. 54E6 is larger than 5400 and so is 59E6. So the only possibility left for D is 3. Let's focus on B next, which is this digit here. There are only two possibilities left for B, 4 or 9. If we look at the result 53E6, this is close to 5400, a little bit less than 5400, and we know that 200 times 27 is 5400. So what that tells us is that the first operand 1B B8 should be close to a 200. So instinctively B should be a 9 because that makes 1B8 198, which is close to 200. But let's check 4 to make sure that 4 is not the right choice. 148 times 27. Let's estimate this. The first operand is less than 150 and the second operand is less than 30. So the result will be less than 4500. 148 times 27 is less than 4500, which means it cannot be 53E6. So that tells us that 4 is not a possibility. The only possibility left for B is 9. There's only one missing digit now, which is 4, and only one slot remaining. It must belong here, but let's check our solution. Instead of calculating 198 times 27, I'm going to do 200 minus 2 times 27 and split it up. So 200 times 27, we already know that it's 5400. Minus 54. So if you write that down, 5400 minus 54 gives us 10 minus 4 6, 9 minus 5 4, and 53.